Okay, everyone, let's take a look at this question. It says, Margaret has found out that by a proper choice of gears, she can steadily increase her speed on her bicycle. So one day she sets out, and 10 minutes later she achieves her cruising speed of 30 kilometers per hour by increasing her speed steadily. Now, how far did she travel in that 10 minutes? Now, what they've done here is they have given us the acceleration. Now, the acceleration is steady, we read here. So remember, acceleration is change in velocity over the change in time. Now, in this case, that's going to be 30 kilometers per hour minus 0, because she starts from scratch. She's not moving. And that's going to take, and here's, I think, where some people might get messed up by this. I don't want you to do this in terms of hours. Wow. I'm circling around here. In my head, I'm moving around too fast here. We don't want to do this in terms of minutes because we've got our speed in terms of hours, okay? Or, I mean, you could do it the other way and make everything in terms of minutes here, but I'm going to choose to do it in terms of hours. So I've got 1/6 of an hour minus 0, the starting time here. 10 minutes is 1/6 of an hour, which means, putting this together, we get 180 kilometers per hour squared. So that's her acceleration here. So we know that the derivative of velocity is going to be acceleration. So when we go and take the antiderivative and take this back to velocity, we're going to get 180 t plus c. Now, we already know that at t equals 0, v is equal to 0, which allows us to conclude that the arbitrary constant that we get out of here is going to be 0. So therefore, v is simply going to be 180 t. But we got to take it one step further. Velocity is equal to the displacement, the derivative of the displacement, so it will be 180 t. And so now when we take the antiderivative, that'll be 180 t squared over 2 plus c. And at t equals 0, the displacement will equal 0, because all we're trying to figure out here is how far she's gone from her starting time. I don't really care where she started from, so I can just arbitrarily set that equal to 0. And once again, we'll get that c is equal to 0. So s is going to equal 90 times t squared. So now all I want to do is figure out, well, how far did she go in that 1/6 of an hour? So that's going to be 90 times 1/6 squared, and that'll end up being 5/2. So really, we will have gone, or she will have gone 2.5 kilometers in 10 minutes.